Hey, I'm Nikhil Diwan.
Hey, I'm Shivan Saraswat.
शिवांश है what's up? Good. आज हम एक थोड़ा टेक्निकल क्वेश्चन देखेंगे. That says minus pi by 4 to pi by 4. Law of sin x plus cos x.
Yes.
Alright. In order to start with a very promising note, what I should do is I should consider the content as I. Because if at any point of time I realize something of same sort going over there, I would replace it by I. Alright. So very interestingly, we have one property which says if you have minus a to a, then check whether the function is an even function or an odd function. So for even function, what we need to do is if we need to check whether f of x and f of minus x deliver same result. Here, if I put in minus x over here, I would be getting minus sin x. But here, cos minus is cos x. No sign change. Hence, there is a sign change in the partial thing but not completely. So eventually we can say that negativity is not occurring, odd function is not there, even function is not there. So that kind of property is not being useful here. I have one more property which says if we have to integrate a function from a to b, I can get the same result if I integrate a to b f of a plus b minus x, and that means this plus this minus x. Since they both are additive inverse of each other, so this plus this happens to be 0, right? So I can have the same result if I put sine this plus this minus x, that means sine minus x over here and minus x over here as well. So, due to some basic trigonometry content, I do understand that log minus x is log cos minus x is cos x, whereas sin minus x is minus sin x. Shivansh, so you have this and you have this. So what do you think? If I add these two, so log a plus log b. What do you think? What is log a plus log b?
Log AB.
Log AB, good show, Shivansh. That's bullseye. So, Shivansh, log A plus log B, यहाँ पे तुम्हें क्या दिखता है? Log sin x plus cos x plus log sin x minus cos x. That means log cos x plus sin x plus log cos x minus sin x. So what do you think log AB means? Log
Cos square x minus sin square x.
Oh, that's pretty good. That means Shivansh has rightly said log of cos x plus sin x plus log of cos x minus sin x means log of cos x plus sin x dot cos x minus sin x eventually log of cos square x minus sin square x. Shivansh, do you remember what is cos square x minus sin square x?
Yeah, sin cos 2x.
Cos 2x. That's good show. So can I write directly cos 2x over here?
Yes.
All right. 2 I have written 2 I over there, right? So cos 2x. Now, this can be a quotient itself, log cos 2x. So now this is a different thing altogether. You know whatever you are witnessing over here and whatever you are witnessing over here, they are completely different scenarios. All right. So I should give it one more try, that whether it is that odd function or even function. So if I put in minus x over here, cos minus x happens to be cos x. So this happens to be an even function. Alright. So 2i is equal to 2 times 0 to pi by 4 because it's an even function. Alright. That allows me to write cos log of cos 2x. So we don't have the coefficient of x as 1. So what do you suggest, Shivansh?
Substitution.
Substitution, alright. So I need to take 2x as m for that matter. If I will be differentiating it, I will be getting 2 is equal to dm by dx and 2 is equal to dx is equal to dm by 2. Great work. So I have I need to handle the limits as well. Lower limit, upper limit at the time of x, at the time of m. So lower limit is 0. Upper limit is pi by 4 at the time of x, when at the time of m, 2 times 0 is 0, 2 times pi by 4 is pi by 2. Alright. So I have 0 to pi by 2 log cos m, not dm by 2. If I take 2 over here, 2I is equal to 0 to pi by 2 log cos n dm. Alright, so if I'm summing it out right now, I have reached this kind of situation which says 0 to pi by 2 log cos n. So, whenever Shivansh, I have 0 to pi by 2 kind of thing, 0 to something kind of thing, I attempt that 0 to a minus x here. So, if I did pi by 2 minus m, I would be getting, can you suggest me, cos pi by 2 minus m is?
Sine.
Sin m, great. What if I add these two? What do you suggest? Log cos n plus log sin n.
Log cos m into sine.
Alright, log cos n into sin n. So, do you have any trigonometric identity which has sin a cos a?
Yes, so we can apply into 2 and upon 2.
Absolutely. So, if I introduce 2 and just have an nullifying impact as well, I would be getting 0 to pi by 2 log sine 2n upon 2, that means log sine log 2. Alright, fair enough?
Yes, sir.
So, again, we have a coefficient of m as non-1. So, what do you suggest?
Substitution.
Substitution? Great, good show. 2 let 2m is equal to t. Differentiate with respect to m. You get 2 is equal to dt by dm. And eventually, dm is equal to dt by 2. Alright, that's 4i remains as it is. I need to handle the limits as well. Lower limit, upper limit at the time of m, at the time of t, 0 to pi by 2, 2 times 0 is 0, 2 times pi by 2 is pi, 0 to pi, then I have log sine t, dm happens to be dt by 2, minus, I can integrate it, x log 2, pi by 2 to 0. Alright. So, Shivansh, whenever we have 0 to something, we attempt that something minus x, right? If we witness f of something minus x comes out to be f of x itself, then we have an identity, a property which says 2 times 0 to something upon 2, f of t or f of x here. So I can add 2 times 0 to half log sine t dt by 2. That 2 gets cancelled.
Yes, sir.
Minus pi by 2 log 2 if I apply the limit. Shivansh, do you see I have the same content log sine t as I had here.
Yes, sir.
Only m and t as they are just the variables, right? So I have 2i here. So 4i is equal to 2i minus pi by 2 log 2. If 2i comes here, 2i is left over. So I happens to be minus pi by 4 log 2. Clear?
Yes, sir.
Alright, thank you so much, Shivansh.
Thank you.
Let's work hard.